Think about all the energy we use on Earth, every car, every plane, every light bulb. Now imagine harnessing all that energy for years and it's still not enough. That's the crazy reality of interstellar travel. Just to reach our nearest neighboring star system would require a mind-boggling amount of energy, far more than our planet currently produces. It's a daunting challenge, but not insurmountable. Scientists and engineers around the world are working tirelessly to unlock the secrets of the universe and develop technologies that could make interstellar travel a reality. We're talking about harnessing the power of antimatter, riding the cosmic winds on solar sails, and even bending the fabric of space-time itself. The possibilities are as vast as the universe itself. The journey of 1,000 light-years begins with a single step, understanding the sheer scale of the challenge. Light travels at 186,000 miles per second, taking over 4 years to reach Proxima Centauri. Voyager 1 would take over 70,000 years to get there. We need technologies to propel us across these vast distances. Let's explore exciting concepts like antimatter propulsion, solar sails, and warp drives. These once sci-fi ideas are now being seriously considered. Join us as we delve into interstellar travel and the technologies that could make it a reality by 2050. 2050 may seem distant, but it's just around the corner. To achieve interstellar travel, we need to push the boundaries of science and engineering now. Imagine traveling to other star systems as easily as we travel continents today. It sounds like science fiction, but it's a future we can make possible. We're talking about human beings exploring new worlds and civilizations. Incredible discoveries await us: new planets, stars, galaxies, and perhaps new life. To make this dream a reality, we need a powerful and efficient energy source. We've all heard of fossil fuels, nuclear power, and even solar energy, but to reach the stars, we need something even more powerful. Something that can release unimaginable amounts of energy from a tiny amount of fuel. Enter antimatter, a substance that exists as the opposite of normal matter. When antimatter and matter collide, they annihilate each other, releasing pure energy. This energy release is orders of magnitude greater than anything we can achieve with conventional fuels. It's estimated that a single gram of antimatter could produce as much energy as the atomic bomb dropped on Hiroshima. Imagine the possibilities if we could harness this power for space travel. A tiny amount of antimatter could propel a spacecraft to a significant fraction of the speed of light, making interstellar journeys within human lifespans a real possibility. Of course, producing and storing antimatter is no easy feat. It's one of the most expensive substances on Earth, and we're still in the early stages of understanding how to handle it safely. Traditional chemical rockets, while powerful, are simply not efficient enough for interstellar travel. They require massive amounts of fuel, which makes them heavy and expensive to launch. To break free from the constraints of chemical propulsion, we need to think outside the box. One such out-of-the-box idea is the solar sail, a concept that's been around for centuries but is now gaining serious traction. Imagine a giant reflective sail, thinner than a human hair, but hundreds of meters across, unfurling in the vacuum of space. Instead of wind, this sail harnesses the power of sunlight. Photons from the sun, though massless, carry momentum. When they bounce off the reflective surface of the sail, they transfer that momentum to the spacecraft, propelling it forward. It's a slow and steady process, but over time, a solar sail-powered spacecraft could reach incredible speeds, all without carrying a single drop of fuel. This makes solar sails an incredibly attractive option for long-duration interstellar missions. Tapping into the cosmic power grid. Solar sails are a fascinating concept, but what if we could tap into an even more powerful energy source, one that's constantly bathing our planet in radiation? I'm talking about the sun itself. Fusion power, the process that fuels the sun, has long been considered the holy grail of energy production. By replicating the conditions found at the sun's core, we could unlock a near-limitless source of clean energy, enough to power our civilization for millennia. While we haven't quite cracked the code of sustained fusion reactions here on Earth, significant progress is being made. Experimental reactors are getting closer to achieving the elusive ignition point, where the energy output exceeds the energy input. Imagine a future where spacecraft are powered by miniature fusion reactors, drawing fuel from the interstellar medium itself. Such a technology would revolutionize space travel, allowing us to venture far beyond our solar system with unprecedented speed and efficiency. But what if we could bypass the limitations of traditional propulsion altogether? What if, instead of traveling through space, we could manipulate space itself? That's the mind-boggling concept behind warp drives. a theoretical technology that has captivated science fiction fans for decades. The idea is based on Einstein's theory of general relativity, which states that gravity is not a force but rather a curvature in the fabric of spacetime. Just as a bowling ball placed on a trampoline distorts the fabric, massive objects like stars and planets warp the spacetime around them. A warp drive, in theory, would create a localized distortion of spacetime around a spacecraft. By compressing space in front of the ship and expanding it behind, the ship would essentially be riding a wave of spacetime, allowing it to travel faster than the speed of light without violating any laws of physics. One of the most well-known theoretical frameworks for a warp drive is the Alcubierre drive, proposed by Mexican physicist Miguel Alcubierre in 1994. Alcubierre's solution to Einstein's field equations describes a warp bubble that would contract spacetime in front of the spacecraft and expand it behind, effectively moving the spacecraft forward. While mathematically sound, the Alcubierre drive requires a form of exotic matter with negative mass-energy density, something that has never been observed in the universe. However, recent breakthroughs in theoretical physics suggest that such exotic matter might not be as impossible as once thought. Some physicists believe that the vacuum of space itself might possess subtle quantum fluctuations that could be manipulated to create negative energy densities. Of course, it's important to remember that warp drives, antimatter propulsion, and even fusion power are still highly speculative technologies. We're talking about engineering challenges that are orders of magnitude greater than anything we've ever faced before. But that's the beauty of science and exploration. It's about pushing the boundaries of what's possible, about daring to dream big, and then working tirelessly to turn those dreams into reality. Antimatter, a concept from science fiction, has a firm basis in reality. It's the mirror image of ordinary matter, with particles like antiprotons and positrons. When these meet their counterparts, they annihilate, releasing pure energy. This energy release far surpasses chemical reactions or nuclear fission. A gram of antimatter could power a spacecraft for years. However, producing and storing antimatter presents significant hurdles. Research at CERN explores ways to produce, trap, and manipulate antimatter. Imagine a spacecraft propelled by the gentle pressure of sunlight. Solar sailing uses the momentum carried by photons, the particles of light. Photons transfer momentum to a reflective surface. A solar sail acts like a giant mirror, gaining a tiny push with each reflection. This continuous force allows gradual acceleration, reaching remarkable speeds. Solar sails require no onboard fuel, reducing mass and launch costs. Several missions are in development, showcasing the potential of solar sailing. While the concepts of antimatter propulsion, solar sails, and warp drives ignite our imaginations, we must acknowledge the immense engineering challenges they pose. These challenges span multiple disciplines, from materials science and energy storage to propulsion systems and radiation shielding. Developing materials capable of withstanding the extreme temperatures, pressures, and radiation levels encountered during interstellar travel is paramount. Equally crucial is devising efficient energy storage solutions to power spacecraft for decades or even centuries. Propulsion systems capable of generating the immense thrust required for interstellar journeys demand innovative approaches, pushing the boundaries of our current understanding of physics. Shielding spacecraft and their occupants from harmful cosmic radiation is another critical consideration. Despite these daunting challenges, the pursuit of interstellar travel continues to inspire innovation and drive technological advancements. As we push the frontiers of science and engineering, we move closer to realizing the dream of venturing beyond our solar system and exploring the vast cosmos that awaits us. So far, we've explored concepts that, while seemingly fantastical, are still rooted in our current understanding of physics. But what if the key to interstellar travel lies in realms beyond our current comprehension, in the bizarre and counterintuitive world of quantum mechanics? Quantum mechanics, the study of the very small, is full of strange and wonderful phenomena that defy our everyday intuition. One such phenomenon is quantum entanglement, where two particles become linked no matter how far apart they are. Imagine the possibilities if we could harness this spooky action at a distance, as Einstein famously called it. Could we teleport spacecraft across vast distances instantaneously? Could we tap into the zero-point energy of the vacuum, an endless sea of energy predicted by quantum field theory? These ideas may seem like pure science fiction, but then again, so did many of the technologies we take for granted today. If we're talking about mind-boggling energy sources, we can't ignore the elephants in the room, or rather the black holes in the universe. These cosmic monsters, formed from the collapse of massive stars, possess gravitational pull so strong that not even light can escape their grasp. But within their event horizons, black holes hold secrets to the most extreme physics in the universe. Some scientists believe that we could potentially harness the immense energy released by matter falling into a black hole. This could involve capturing Hawking radiation, the theoretical thermal radiation emitted by black holes, or even creating artificial mini-black holes and extracting energy from their decay. Of course, harnessing the power of black holes presents its own set of mind-boggling challenges, not least of which is the slight inconvenience of their immense gravitational pull. But hey, if we're dreaming big about interstellar travel, we might as well dream big about our energy sources too, right? As we've journeyed through the mind-blowing world of interstellar propulsion and energy, one thing has become abundantly clear. The limits of our technology are often self-imposed. We are limited only by our imagination and our willingness to push the boundaries of what we think is possible. The challenges of interstellar travel may seem insurmountable, but so did the challenges of human flight, of landing on the moon, of splitting the atom. Yet, time and time again, humanity has risen to the occasion, driven by an insatiable curiosity, a thirst for adventure, and a burning desire to explore the universe around us. The journey to the stars will require not just scientific breakthroughs, but also a fundamental shift in our perspective, a recognition that we are all part of a larger cosmic story, a story that is still being written. From antimatter to solar sails and the concept of warp drives, we've explored technologies that could propel us to the stars. Each presents unique challenges, requiring breakthroughs in physics and engineering. History shows the impossible can become possible. The journey will test our ingenuity and resolve. It will need global cooperation and investment. The rewards would be immeasurable. Imagine humanity exploring new worlds, encountering new life forms, and unlocking the universe's secrets. It's about reaching our full potential as a species. So, as you look up at the night sky, let those twinkling stars serve as a reminder of the incredible possibilities that await us. Let them inspire you to learn more about the universe, to support scientific research, and to never stop dreaming of a future where humanity takes its place among the stars. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment. We'd love to hear your thoughts on these groundbreaking concepts and the future of interstellar travel. Do you think we'll reach the stars by 2050? What technological breakthroughs do you think will be most crucial? Share your thoughts in the comments section below and let's keep the conversation going. Until next time, keep looking up and keep exploring the wonders of the universe.